Hi, Addy. Welcome to lesson number 96, and today's lesson is going to be super fun. I actually looked at this lesson in advance, and I was like, whoa, this is really some advanced stuff. In fact, Zach and I have been working on functions this year for him. So you're going to be talking about functions today and also graphing functions, which is really the next step. Very advanced math. You are definitely going to be an awesome math nerd next year, and you should be proud of that. Okay, I actually saw you today doing your math test, and I saw that you were doing your math homework in pen. I too like to live dangerously. That's a lot of confidence if you're doing your math test in pen. I love it. Okay, let's jump right in. We're going to do some mental math, and the first thing that we're going to do is we're going to count by 1/16 this time, all the way from 1/16 to 1. Now, we're not just going to do 1/16 and follow that by 2/16, because 2/16 is the same as an eighth. So we're going to reduce these fractions as we go. And so that's why I got this to help me. But you could probably do it in your head when you go from 1/16, 2/16, 3/16, 4/16, and you'll be able to figure it out and reduce it, right? All right, here we go. We'll start with 0, 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, 7/16, 1/2, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16, 1. And this is really cool as I saw us doing it on this thing, because if you'll notice, every other one gets reduced. So this doesn't get reduced because it's an odd number. All of our odd numbers don't get reduced to something else. I mean, they are already in their reduced form, but these you have to change the fraction, right? Instead of 2/16, it's 1/8, and instead of 4/16, it's a fourth. 8/16 is going to be that. So I like this picture on the ruler because it shows you the 5/16 are already in their most reduced form, or the odd ones. So that's really cool. All right, let's do the rest of mental math. Ready? We're going to do 70 times 90. Write your answer. B is 364 plus 250. C, what is 50% of 60? I just realized that I forgot to do your 5 minutes of your multiplication facts, but I'll let you just do that on your own, okay? Sorry. D is going to be $5 minus 89 cents. E, what is 100 times 0.015? F, what is 750 divided by 30? I would get rid of those zeros, and then I would just think 75 divided by 3. Like if I have 75 cents, what 3 coins makes it even? All right, G is our long one. You ready? We're going to start with the number 6 times 6. And then we're going to subtract 1. Divide by 5. Multiply by 8. Subtract 1. Divide by 11. Multiply by 8. Multiply by 2. Add 1. And then take the square root of that number. Problem solving. Here we go. We are going to copy this factor tree and fill it in. Okay, so do you remember how to do factors? When you're doing factors, you start with a number here. This number can be divided to get two numbers, x and y, that when you multiply them together, make this number. Okay, and then you divide this one down into 5 times something has to equal this number, right? So we have to, in this factor tree, start at the bottom. So we know that when you have a 3 and a 3, then this number here is going to be 9. because it has to be. It can't be anything else. When you factor the number 9, you get 3 and 3. And what number do you factor to get 2 and 2? Well, it's going to have to be 4, right? Because you have to multiply those together. And then just work your way up the tree and see what you get for this number, okay? Alrighty, cool. Let's move on to the new concept because this is going to take a little bit. The new concept is about functions. Now, functions sounds like a complicated math term. It's not. I'm going to explain to you how functions are kind of like a machine. Let's start with Gwen. Now, this is Gwen Stefani, I think, and she's like, what? I don't think she would know how to do this, but you're going to know how to do this by the end of this. So Gwen thought of a rule, okay? It's a math rule, and this is going to be Gwen's rule. And she thought of a rule that used the length of the side of a square. So I'm going to delete this and draw a square for Gwen. Okay, so Gwen's rule is that if you know the measurement of a side of a square, and I'll call it S, and you know that whenever you're talking about a square, that all the sides are even. It's an equilateral polygon, right? So S is the same wherever. So if you know one S, you know what the length of every side is. Okay, so she thought of a rule that used the length of a side of a square to find the perimeter of the square. Now, how would you find the perimeter of this square, right? You would do S plus S plus S plus S because there are 4 sides to a square. You can add all those sides together, or you can make it simpler and do 4 times S, or 4S. Okay. But Gwen didn't, anyway, Gwen's rule is if I know the side of a square, I multiply the side of the length by 4 to get the perimeter. And then she figured out that rule and she made a table. And here's the table that she made. On this first column, these are all sides of squares. So if the side of the square is 5, like you plug in a 5 right there, what's the perimeter is going to be? Well, it's going to be 5 plus 5 plus 5 plus 5, or 4 times 5. And so the perimeter is going to be 20. Whoops, didn't mean to erase that, but there we go. All right. And if the side of the square is 7, the perimeter is going to be 28. If the side of the square is 10, 10 plus 10 plus 10 plus 10, or 10 times 4 is 40. So Gwen's rule is multiply the side length by 4 to find the perimeter. Another way to state Gwen's rule is this. The perimeter is equal to 4S, or 4 times the side length. Okay? So the number that should replace the question mark here, what's it going to be? Well, let's use her rule. Her rule is the perimeter equals 4 times S. You don't have to make that little dot for times. You can just say 4S, and it's the same thing. So the perimeter here is 4 times 15. And you can do that in your head probably because you've been so good at doing mental math. The answer is going to be 60. So 60 goes right here. If the side is 15, the perimeter is 60 according to Gwen's rule. Now, Gwen's rule can also be called a formula or an equation. And this is the equation that you use every time you know the side of a square and you want to find the perimeter. So a formula like this or an equation like this is an example of a function. And the way I think about a function is like a machine. And every machine has its own equation or its own formula. And so for Gwen's rule, I'm going to write perimeter is equal to 4S. And this is what this machine does. So if you put in this value for S, it goes into the machine, it goes, it shakes around. I imagine it sort of shaking around. And then it poops out an answer. And the answer that is going to get pooped out is the perimeter. And it all depends on what this machine does. But if you put in any sort of number, like you can put in a 3, a 6, a 10, whatever, you can put in pi, any number that you want. The machine won't break. The machine will plug it into this formula and it will spit out a number for p. So I think of a function as a machine, okay? So in this case, the length of the side is connected to the perimeter by that machine. All right, so the perimeter of a square is a function of the side length of the square. That's another way to say it. The perimeter of a square is a function of the side length of the square. So if you know the side length of a square, you can figure out the perimeter by easily using this function. Let's do example 1. Okay, example 1 says, find the rule. It's going to be a different rule. It's not going to be Gwen's rule. This is going to be, I don't know, it might be Cruella's rule, right? Who knows? Find the rule for this function. Then use the rule to find the value of m when L is 7. Okay, so that is our job. They want us to figure out what is the function when you plug in L, how do you get m? So we don't know the equation, and that equation goes here, okay? So they're saying we're going to plug in L, goes in here, and what gets spit out is m. So they want to know what is the equation. And they gave us this. They know this. Every time they stuck in a 5 into this machine, they put in a 5, the m that came out was 20. So how do you go from 5 to 20? Okay, so we might say if we plugged in a 5 and a 20 spit out, it could be that the function is 4 times 5, right? Because 4 times 5 is 20. So it might be, let's see, let me write it in. M is equal to 4 times L. It could be that if we're only looking at this one, because that would make sense. We plugged in a 5, and if m is equal to 4 times L, then it would spit out a 20. So let's see if that makes sense for the other ones. If we plug in a 10, we dump it in the machine, it would be 40, not 25. So that tells me that the function that I guessed is wrongaroo. That is not the right equation. So now we have to figure out, how do we go from 10 to 25? We're going to look for another rule. Okay, so you might notice that 20 is 15 more than 5. So what if we plug in 5, like on the first one, and we add 15 to it? That would give us a 20, right? So maybe m is equal to L plus 15, and maybe that's the function. All right, let's see if that makes sense for the other ones. What if we put in a 10? If we put in a 10 and we add 15 to that, that would give us a 25. And if we put in a 15, that would give us a 30 if this is the correct function. So maybe the rule is to add 15 to whatever L is. And since all of the values fit that rule, that must be the function. All right, so we found the function. That's step 1. And step 2, we have to figure out what this question mark one is. All right, so if we know the function, this time we're going to plug in a 7 into this machine. That would make this a 7, m equals 7 plus 15, and the number that it's going to spit out is going to be 22. And that goes over here in this table, 22. So we figured it out. We know the function, which is m equals L plus 15, and we know the missing value, which is that 22. Cool. Let's do example 2. Example 2 says, find the missing number in this function table. All right, so the missing number is here. And this one's interesting because they gave us a value for x. So usually x is the thing that goes inside the function, and what gets spit out is y. That's usually how mathematicians define it. So we still need to figure out this. Actually, no, they gave us the function, because if this is x, this is going to be y. So y is going to be equal to 3x minus 2. Let's make sure that that makes sense with all of the numbers that they gave us. Okay, so let's start with this 2. They gave us a 2. So if we change this x to a 2 and plug in 2, and then we plug in a 2 right here, 3 times 2 is 6 minus 2. That would mean y is equal to 4. That's what the machine would spit out. So if we put in a 2, the machine will spit out a 4. Yes, that's correct. If we put in a 3, let's try it, then it's going to be 3x minus 2, so 3 times 3, which is 9, minus 2, which is 7. So this is going to be a 7, and that's correct with this one. So they already gave us the function. They're saying when you put in an x, what you get out for y is 3x minus 2. Okay, so now the last one, all we have to do is figure out that missing value. This should be easy peasy, right? So we're going to plug in this 4. So we plug in 4 into the machine, and then it's 3 times 4, which is 12, minus 2. So y is going to be equal to 10. And that is the missing thing here. It's going to be 10. Easy peasy. So you found the missing number. All right. Now, guess what? The lesson doesn't end there, because we talk about graphing functions next. So graphing functions just means that whatever you have on your table, you can change it and put it into a graph. And the way you do it is, this is the x coordinate system, this is the y coordinate system, and on your little table, these are all the x's, these are all the y's, okay? So that means whenever there's a 1 for an x, you go over 1, you have to go up 4. Now this table, notice that it's not a perfectly balanced system. Like this is 1, 2, 3, 4, 5, 6 to here, but this is counting by 4s, 4, 8, 12, 16, 20, 24. And they did that because if they counted by 1s on this side, then the dots would be like doo, doo, doo. It would be like way too steep for us to see. So all they did was they changed the scale on this side, and that's perfectly acceptable. That's totally fine. You can do it as long as you defined what the scale is to begin with. So this is the length of the side, and these are the perimeters of a square. So if the length of the side is 1, the perimeter is going to be 4. If the length of the side is 2, the perimeter is going to be 8. And this would be like perfectly on a graph paper. 3 goes to 12, and if x is 4, y is 16. Okay, you've got it. And the next thing to do once you have all of these points is that you can hook them together. And you can make a straight line out of it. And it turns out that the relationship between the side of a square and the perimeter of a square is going to be, it's a linear relationship. That means it's a straight line. It's linear. It's a linear relationship, a straight line. Cool. And once you know that line, once you know how to turn the side of a square into the perimeter, you've got a function. I mean, you could do it for anything. Let's say the length of the side is 0.01. Is that a problem? No, not at all, because you know the function is that. So the perimeter is 4 times 0.01. Easy peasy. You can figure that out. So, and you could also use this graph to figure it out. That's another way to do it, but easy peasy, right? All right, let's do one more example. Oh, that's just what I just drew. Okay, example 3. The perimeter of an equilateral triangle. Now remember, an equilateral triangle looks kind of like this, where all the length of the sides are equal. So if this is S, then this is also S, this is also S. The length of the sides are equal in an equilateral triangle. The perimeter of an equilateral triangle is going to be what? If you were trying to figure out the perimeter, it would be S plus S plus S. Remember, it's like if a little ladybug were like walking along, it has to walk that length, it has to walk this length, it has to walk this length. So you just add them all together. The easier way to do it would be the perimeter is 3S. Okay, easy peasy. It says, make a table for this function using side lengths of 1, 2, 3, and 4. So we have to make a table, and these are our side lengths. So it's as if this is 1, and then we're going to put in the number 2, the number 3, the number 4. So first is make a table. So I already started making one right here, and then they want us to graph it. Okay, so if S is 1, what's the perimeter of that triangle going to be? Well, it would be 1 plus 1 plus 1, which is 3. Okay, what if the side length is 2? Well, that's just a triangle that looks like this, and it's 2 plus 2 plus 2, 2, 4, 6. Okay, and you could just like make it easy because I think you're starting to get it. And instead of adding all the S's, you can just say the perimeter is going to be 3 times S, whatever S is. So let's do that for the last two. If S is 3, the perimeter is going to be 3 times 3, which is 9. And if S is 4, the perimeter is going to be 3 times 4, which is 12. Okay, easy peasy. Now they want us to graph it. This is the function. And here's the graph that I started to make. So on the x-axis, because that's this first, this is like the x, this is like the y, right? This whole column is going to be the x's. This next column is going to be the y's. So on the x-axis is what is the length of the side. On the y-axis, it's what's the perimeter of the triangle. So if the length was 1, the perimeter was 3. So I have to go, let's see, 1, 2, 3. It's kind of like right there. It's not exactly, but anyway, something like that. If the side is 2, which is here, the perimeter is going to be 2 times 3, which is 6. That's somewhere right here. Okay, and then you do it for all of them. If the side is 3, it's going to be 9. We figured that out, so it's going to be like right there. If the side is 4, it's going to be 4 times 3, which is 12, which is like right there. I didn't draw very good because it's supposed to be a straight line, which is probably more like that. So, easy peasy, I graphed it. Okay, and then I'm going to put an arrow because it could keep going forever, right? You could have a triangle that's like 1,000,000 millimeters, right? Or something, I don't know. Yeah, so there you go. That's it. That's the whole thing. That is functions and how to graph functions. So if you're asleep like these Dalmatians, time to wake up and time to do your homework. Okay, love you, Addy. Bye.